Alright, so moving on to the last one for this page, a rectangle is bounded by the x and y axes of the graph of this linear function. The length and width should, or at what length and width should the rectangle have so that the area is maximized? Okay, so area is a max. So our primary equation should be the area of this rectangle wherever we want to draw it within this particular triangular shape. So it doesn't necessarily have to be this rectangle, it could be any rectangle that we want to draw. For instance, maybe it would look something like that. So the area of a rectangle we know is base times height, and if we were to think about on a coordinate system, usually the base of the rectangle would represent an x value and the height of the rectangle would represent a y value. So we use x and y for the length and the width. The issue with this is notice how we have two variables in here and we just typically want one of them, that way we can try to find a critical point. So there has to be some secondary equation that we can either think of or use to help us rewrite one of these variables, either changing an x into a y or a y into an x. And if we think about it, notice how the height, okay, the y value from this rectangle specifically comes from the linear function itself, which we know the equation of. So this is actually going to be our secondary equation for this example that we can go ahead and plug in for y. Alright, so let's clean it up before we take a derivative. We'll have 3x minus 1/2 x squared. And to find our critical points, where a potential maximum might be located, we'll go ahead and take a derivative. So there's our derivative using our power rules, set it equal to 0. Looks like a critical point would be at 3. Okay, so we have to test it though. Maybe it is a maximum, maybe it's not. Let's see what happens. So we'll do, don't really know, lower bound, probably could guess 0, okay, because the x distance would be 0 if you don't have that width. So 0 to 3, and then 3 to, based off the drawing, we could probably assume we'll stop at 6. But again, you don't really have to label what the lowest and highest values are, as long as you show that you're testing a little bit before and a little bit after 3. That should be perfectly fine. Alright, so something in between, or something a little bit less than 3, maybe 2. If I plug it into my derivative, it'd be positive. And anything a little bit bigger than 3, if I plug it in, would be negative. So we just confirmed that we have a maximum at 3. So we'll say area is maximized at x equals 3 because the derivative changes positive to negative. Okay. Now to specifically answer the question though, they do want the length and the width. So we know that x value is 3, so we have that base distance, but we do also need to figure out the other dimension of the y. So if we know an x, how can we figure out a y? Maybe we can just use the equation that they gave us for the line. So we'll say x is 3 and y is, if I plug in 3 for x, this would be 1.5. So 3 minus 1.5 is 1.5. So there's our other coordinate.